I
Hi.
am Selvi Kadarwal, and I'm the engineering lead at Allotl, and I'm excited to be sharing our work on automating disaster recovery for FerretDB using Nova. The work presented here was led by Maciej Karbansky of Allotl. Let's begin with an introduction to what Nova is. Nova is a multi-cluster orchestrator that helps manage a fleet of Kubernetes clusters, irrespective of whether these clusters are kind clusters on your laptop or cloud provider managed clusters, or a combination of the two. Nova's capabilities for fleet management can be categorized into day 0 ops and day 2 ops. Let's look into details for each of these categories. For day 0, Nova primarily maps your workloads to specific clusters in your fleet. This mapping is captured by what we term as a schedule policy, which is a Kubernetes custom resource that the user defines. These schedule policies can be static or dynamic. In a static policy, the user clearly specifies which target clusters their workload needs to run on. So for example, I could request Nova to run my application A on clusters 2 and 3. In a dynamic policy, such as capacity-based scheduling policy, the runtime conditions on your fleets as well as the resource needs of your workloads will determine at runtime where your workloads will run. For example, you could request Nova to run your machine learning training workload on any one of your team's dev clusters that has sufficient capacity. So now, with the help of Nova scheduling policies, your workload is running on the clusters you need them to run on. Now let's look at what Nova can provide as day 2 fleet management support. For day 2 operations, Nova helps with 3 different aspects. The first one is workload migration. This allows the user to move their workloads from one cluster to another. These migrations are triggered either by a change to the schedule policy or, more interestingly, triggered by changes in the resource needs of your application. For example, for your training machine learning workloads, if you needed to change a deployment's replicas from 10 to 20 and its current target cluster does not have sufficient capacity, Nova can intelligently determine this and migrate your workload to another cluster with sufficient capacity. Let's move to just-in-time cluster capability in Nova. This allows Nova to create new clusters from existing cluster templates triggered by incoming workloads. This means that you don't have to be paying for your cloud clusters when you don't need them. The JIT feature also helps with cost optimization in another way. It allows a cluster without workloads to be brought into standby mode. That means zero worker nodes, or even deleted completely. That is, both worker nodes and the control plane can be brought down. Now that we have a sufficient background on what Nova is and its role in fleet management, let's move to the focus of this talk: automation of disaster recovery. Disaster recovery refers to the process of executing a predetermined DR plan that is needed to bring back your application, in this case your database, back to its fully operational state. The failures of interest here are cluster level failures, zone level failures, or even region level failures. So first, let's look at why do we need to automate in the first place. Automation significantly reduces your recovery time objective. This is the time from which your failure occurs to the time when your application is back into its fully operational state. Every bit of outage time that is reduced helps reduce loss in terms of revenue and reputation for your business. Secondly, it reduces potential user errors in handcrafted automation scripts that need to be carefully run during an already stressful situation. And most importantly, it allows for fire drills. A DR plan that is not well tested can easily go stale. One that is automated will encourage your teams to tolerate these fire drill interruptions frequently. Next, we'll talk about why do we need to use an orchestrator like Nova for automating DR. Nova is uniquely positioned to both have visibility into your cluster fleet as well as control of the workloads running on your fleet. This makes the automation possible. So, as shown in the diagram, if your primary database is running on workload cluster 1 and your standby is on a second cluster, Nova can make modifications to these workload manifests on the fly. For example, for invoking standby promotion, which is an essential step in the DR plan. Another example is end-user traffic redirection, which would require a change to your load balancer configuration. Finally, we look at a benefit of how Nova implements this automation. Nova as a management tool presents a Kubernetes API to the user. This allows for the entire DR workflow to be captured in a Kubernetes native way through a custom resource called the Nova Recovery Plan. Let's dive into this recovery plan in the next slide. The Nova Recovery Plan captures a sequence of steps that needs to be enacted as soon as a failure is detected by Nova. Each recovery plan is associated with a unique label called the alert label that you can see here in the code snippet in the slide. Such an alert is pushed from your monitoring setup to Nova. After the alert label in the recovery plan is a list of steps that will be invoked in the provided order. There are two types of steps. A patch step is one in which we specify how the manifest of a running workload needs to be modified. In a read step is one in which a runtime value is read in by Nova and will be used in a subsequent recovery step. In the example, the path step modifies a field identified by the path spec.standby.enabled and sets its value to true. This would be one part of standby promotion. In the following read step, we read in a field path load balancer.ingress.hostname, and this IP or hostname will then be used to reconfigure your load balancer for end user traffic redirection. This is only a simplified sample of a recovery plan. Next, let's look at how we would capture DR for a FerretDB setup. This diagram shows one possible setup for DR for FerretDB using Percona operator for Postgres. On workload cluster 1, we see the Nova agent, Percona Postgres cluster, and FerretDB. Percona is set in the primary mode here. On the second workload cluster, we see the same workloads, with one difference being Postgres operating in standby mode. Both the Postgres clusters use an S3 bucket as their data store. In the third workload cluster, HA proxy is deployed and is used as a load balancer between the primary and the standby. The recovery plan for FerretDB has 4 phases or steps. The first is a patch, which transforms the primary to a standby. The second is also a patch that transforms the standby to primary. The third step is a read, where the host name of the standby is read in. And the final step is a patch to the HA proxy configuration so that new Mongo client request will be forwarded to the new primary. Let's now look at what happens when the primary cluster experiences an outage. At the time of an outage in the primary DB, a predefined alert is generated by the monitoring stack and sent to Nova. The corresponding recovery plan is selected by Nova and converted into an internal structure called the recovery run. This can be queried if necessary to determine the status of where we're at in the process. At the successful completion of the recovery run, Mongo client requests are redirected to the standby cluster. And voila, all of this was possible without any user intervention. We'd love for you to try out Nova. The key takeaway from our session is that Nova is a fleet management tool that can enable easy automation of your DR workflows for powerful databases like FerretDB, Postgres on Kubernetes. The easiest way to try Nova is through the GitHub link on this slide. We'd love to hear from you. If you have feedback, complaints, or other requests for Nova Day 0, Day 2 ops, please write to us and join our Slack channel. Thank you.